There we go. All right, so we're lesson 4-1. We're talking about factors and monomials. Have you guys ever heard of the word monomial? No. So that's going to be a new thing. It's actually something you've dealt with in the past. It's not like new as in you've never dealt with it before, but it is a term we need to get comfortable with as we get further on. Okay, what's a factor though? Because I dealt with factors before. So anyone know what a factor is? Yep.
Isn't that the answer to a multiplication problem?
I think you're thinking product. Yeah, product is the answer to a multiplication problem. What's a factor? Yep.
Isn't that the one in the multiplication problem?
Okay, it's a number in a multiplication problem. And anything else you want to add to it?
Is it it's like the same thing as multiplying by a number?
Okay, you're getting there. Both of you gave me good parts of it. So I want you to write this definition down. The factors of a whole number, so we're talking about whole numbers here, not decimal numbers or fractions, although we will get to that later. The factors of a whole number divide that number with a remainder of 0. Okay, so it's any number that can divide another number where when you do that division, you get a remainder of 0. Okay? So I'll give you an example and see if you can figure out what that means. Because that's kind of like theoretical. Like, yeah, I get that kind of. But let's pick a number. Let's pick the number 12. Excuse me. Thank you. All right, so 12. What are the factors of 12? What are the factors of 12? So what numbers can go into 12 evenly? Is I guess what I'm asking. Give me one. Chelsea? 1. Nice. Give me another one. 2. Look at you guys on a roll. Cole? 3. Hey, this is fun. Yes? 4. Oh, I think I know the next one. It's got to be
6.
Oh, yeah, I guess it is 6. Next one?
12.
Yes, ma'am? 12. Huh. Okay, let me see if you guys follow me here. Please look up at the board. Watch the finger as it's going everywhere. Okay. Does 12 divided by 1, when I do that division, does it give me a remainder? No. 12 divided by 2, does it give me a remainder?
No.
12 divided by 3?
No.
12 divided by 4?
No.
12 divided by 6?
No.
12 divided by 12?
No.
Okay, but remember how I was getting to the pattern 1, 2, 3, 4? And I really wanted to say 5. But is 5 really a factor of 12?
No.
Okay, can 12 be divided by 5? And the answer is yes, it can be. But will it have a remainder of 0? No, it will have a remainder of 2. So it doesn't go into it evenly. 5 is not a factor of 12. Okay, you guys get that? All right, next concept here, and this is where I want you to get these ideas down. Okay, I'm going to pick a number. 6 is a factor of 12. Would you guys agree with me on that? 6 is a factor of 12. And the reason I want to say that is because we should know that. Yes, I get that. But then I'm going to come up with another statement that uses those two same numbers in a different way. And this key word is going to be what our lesson is about. If 6 is a factor of 12, then 12 is, and then here's a key word, divisible. Have you ever heard of that? Have you ever heard of divisibility rules? Okay, 12 is divisible by 6. Okay? That's what I want you to get down. If 6 is a factor of 12, then you can reverse that statement and say 12 is divisible by 6. Okay, that word divisible, that's kind of a tough one. I'm like, how do you define divisible? This is how I do it in my head. Ready? I come up with a new word. It's not in the dictionary, so please don't quote me on it. I say 12 is, here it is, dividable by 6. That's not a word. Please don't quote me. Dividable. What I mean by that is 12 can be divided by 6 with no remainder, right? Can 12 be divided by 6 with no remainder? Yeah, so then I say 12 is divisible. You guys don't like that word? Is it a word? I don't know. Maybe it is. Maybe in a few years it will be. How about that? Okay. I don't think it's a word as of now, but it might be. All right. Here's the key concept. We're going to talk about the divisibility rules. Not all of them, but divisibility rules. And you should know a lot of them already. But if you don't, this is the time to get it down. So I need you to get these rules down for these numbers particularly. We're not doing all of them. We know divisibility rules for 2, 3, 4, 5, 6, and 10. But there are divisibility rules for like 7. They're just really complicated. So we're going to go over some of those, and I hope not the harder ones. Okay, does anyone know what the divisibility rule for 2 is? So how do I know a number is divisible by 2? Cole? Okay, I like that one. And for everyone else, I'm going to help you out to make sure you get that. If the ones digit is divisible by 2. What? That seems really complicated. Yeah, basically if the number's even. Do you guys understand the word even, what it actually means? It can be divided by 2 evenly, right? You can split up in half evenly. So that's what it means by divisible by 2. If the ones digit is divisible by 2, so what digits can a number end with to be divisible by 2? Give me all of them.
1, 2, 3, 4, 5, 6.
You got some of them. Parker?
B. Any variable. What?
So I'm thinking divisible by 2, and B could be divisible by 2, but so I hope it's not too complicated. Jake?
2, 4, 6, 8.
2, 4, 6, 8, and there's a special one. 0. 0 is divisible by 2. And you're like, wait, what? 0 can be evenly split. Okay? 0 is an even number. And you're like, wait, 0? How does that work? Okay, we'll get to that. I'll try to explain it. But that's the rule for 2. All right, by 3. Does anyone know the rule by 3? Divisibility by 3. I know Cole knows it. Does anyone else know it? What's divisibility by 3? This is a cool one. I think it's really cool. Yes? That's going to be for 4. You're getting it for 4. I think Sarah might know. Go ahead. Yes. All right. Ready? If the sum of the digits is divisible by 3. Okay? Well, and we're going to apply this. We're going to actually look at it and see what we mean by the sum of the digits, because some of you, not that sum, the other sum, or is it that sum? Some of you are thinking something, wow, so many sums. Sum refers to addition of the digits. And if that sum is divisible by 3, then the whole number would be divisible by 3. All right, does anyone know? I'm going to skip 4 for now. Does anyone know the divisibility rule for 5? This one's a nice one. There is a 4, but just skip it. I'll get to that later. Peter? Joshua?
If this ones digit
Not that one, sorry.
0 or 5.
Okay, if the ones digit. Now, do you notice I keep saying ones digit? Why don't I just say the number ends with 0 or 5? If the ones digit is 0 or 5. Does anyone know why I don't just say the last digit? Yep. Okay. Cole? Yeah, so let me give you an example here. All right, ready? I'm going to give you a number. 350.2. Is that divisible by 2?
No, maybe.
Okay. It goes into it evenly, but what are we talking about in this lesson with our numbers? We're talking about whole numbers. So is that a whole number? No, it's a decimal number, so we're not talking about that. Is 350 divisible by 2?
Yes.
Is it divisible by 3?
No.
Mm.
No.
Okay, so this is what I do. What's 3 plus 5 plus 0? 8. Is 8 divisible by 3? So not divisible by 3. So good. That's good. And is this divisible by 5? Because the ones digit is 0 or 5, so it's divisible by 5. So that's how you test it out. And that's what we're going to do later on this lesson. Oh, my favorite, by 6. It's my favorite one. All right, Davis? Okay, good. And you use the key word there. Little did you know, Davis. You know what that key word was? Divisible is always in there. If it's divisible, by, I haven't gotten that key word yet, by 2, and is the key word 3. So, according to this rule, by 6, if the number is only divisible by 2, is it divisible by 6? No. If it's only divisible by 3, is it divisible by 6? If it's divisible by 2 or 3, 2 and 3, see, that's where the keyword works. If it's divisible by 2 and 3, is it divisible by 6? Yes. It has to be by both. Come on, guys, we're almost done here. And by 10. The toughest one out of them all. No, not 7, 8, 9. Although there are rules for those. Yep.
The ones digit is 0.
Good. If the ones digit, there you go, ones digit. There you are again. If the ones digit ends or is 0, that's the rule. So back to this number, 350. Is it divisible by 6? By 6.
No.
Why not?
Because it's not divisible by 2 and?
Good. It's divisible by 2. Would you agree with that? But it's not divisible by 3. Therefore, it can't be divisible by 6. But what about by 10?
Yes.
Yeah, the ones digit 0, so it's divisible by 10. All right. And then the nice 4. 4 is a special one. Does anyone know what that rule is? It's kind of hard to explain. Does anyone know it? Yes, ma'am. Sarah?
Isn't it if it's like, I know it's like if it ends in a 4 or 2 zeros or something.
Oh, I see what you're saying. Interesting. You're going around it a little bit. I want a more like direct one. Cole?
Ones and tens digit, and that number, and then 4 can go into that number.
Okay, good. That's it. If the last two digits, and I'm going to make it clear, if the last 2 digits of a whole number, is divisible by 4. All right? If the last 2 digits of a whole number is divisible by 4. All right. So looking at this guy right here, the last 2 digits would be 5 and 0. So think of the number 50. Is 50 divisible by 4? No. So is this 350 divisible by 4? No. Okay, that's how you figure it out, which is really cool. Now, some of you might be thinking in your head, and this is a reasonable thing, Mr. A, I hate rules. In fact, you just added rules to me, and man, why can't we just do it the natural way? Right? I mean, natural. Why do all these things? Do you know what the natural way would be to do these problems? The natural way would be this. When you look at the problems, all they do is give you a number, and they ask you, is it divisible by 2, 3, 6, 5, and 10? The way to figure it out without these rules is simple. You just divide that number by each of those other numbers. So you got to do 5 division problems for every problem. Oh, that's not too bad, right? You want to do that?
Yeah. No.
I heard a yes.
Well, I don't even know if it's right or wrong. So.
No, you could do that, and if you have no remainder, you would know that's one of the numbers that it's divisible by. But I don't want to do that for every single problem. I want to know a rule, and that actually helps me make these problems quicker. Okay, so look at example number 1. Let's see how quick this can be. Example number 1. And Nick, can you do me a favor, and can you read it for me?
Yes, okay. Example 1.
Uh-huh.
So determine whether
Divisible?
Or divisible
Yeah, that's my word there.
by 2, 3, 5, 6, or 10.
Okay, so all I did was, I'm doing this for you guys. I wrote the number down, and then I wrote the numbers that we can choose from. Okay, is it divisible by 2? And raise your hand, and then I'm going to ask you why or why not. So you can say yes or no, why or why not.
Yes.
Yes, why?
Because it ends in
Okay, the last digit is an even number, or is divisible by 2, so that's good. 3,
no.
ma'am?
No, because 5 plus 6 well, 1 plus 4 plus
Yeah, what's 1 plus 4 plus 6? 11, is that divisible by 3? No, so 3 is not, that number is not divisible by 3. All right, 5. Josh?
no.
No, why not?
Because the 1 digit is a 5 or 0.
Yep, it's not 5 or 0, it's not by 5. 6, this should be automatic since you already did 2, 3, and 5. Yes, ma'am?
No, because not by the 2 and 3 going to it.
Yeah, if 2 and 3 went into it, 6 would also be a divisible. That number would also be divisible by 6. All right, 10.
Well, I just have one question.
Go ahead.
So, if the 1's digit, that's the second rule, if the 1's digit is divisible by 2, like...
That just means that the 1's digit is even.
Okay.
Mm-hmm. Yes, ma'am? 10. No.
No.
Why not?
Because it doesn't end in 0.
Oh, okay, good. That's it. Okay, the alternative, ready? I'm going to do it real quickly for you guys. There's an alternative way to do this. Ready? Stay with me. Please, guys. I'm just writing these problems down. Make these easy for us. Okay, the stress level. I feel like everyone's watching me. Okay, this is what you would have to do. You would have to do these 5 division problems and then find out, is there a remainder? Is there a remainder? Is there? Okay, and then you can figure out if it's divisible. How many of you like the rules? Some of you are like, I hate the rules. Well, the rules like you, so don't feel bad about that. Okay. I like those rules. I'm thankful for them. Okay, I want to see if you guys can do it on your own now. So this is not the end of the lesson. We have one more little concept, but I want to see if you can practice this. Page 173. I want you to do number 6. Is 39 divisible by 2, 3, 5, 6, and 10? So you just tell me which ones it is. You don't have to explain to me why or why not. You just have to tell me if it's divisible by 2, 3, 5, 6, and 10. Okay, some of you have the answers. I'm actually going to do it as... Oh, question. Go ahead.
You don't have to write it like that.
No, so you don't have to write the number because it's already there. And then I do this so we can just eliminate. You just have to write the numbers that it is by, divisible by. So these you hardly have to show anyone unless you want to do it the old school way and just divide them all out. Okay, everyone as a class, you're going to say yes or no. Everyone. Is 39 divisible by 2?
No.
No. Does anyone know why not? Yes, ma'am?
Because it has to end in like even number.
Okay, good. So that's it. Is it divisible by 3?
Yes.
Why?
Because...
Ma'am?
Because
Sorry.
3 plus the amount is 12, and 12 is divisible by 3.
Good. So the sum of these digits is divisible by 3. By 5?
No.
Why not, Nick?
Because the 1's digit is not 0 or 5.
Good. 6.
No.
Okay, why not, Josh?
It doesn't end in a 2, or it's not divisible by
2
2.
and
And
3. Good. And I think I knew what you meant. Since it's not divisible by 2 and it already was by 3, it can't be by 6. So I got it. Gotcha. And then by 10?
No.
Why not? Sarah?
It has to end in a 0.
Oh, okay, good. So it's only divisible by 3. That's all I want on that number. Does that make sense? That was an easy one. Number 8. 876. Number 8. Is it warm in here?
Yes.
All right, I will change that as best I can in just a moment. 876. Everyone, by 2.
Yes.
Yeah, I like that. Yes. So easy. Right? You got it. I'm good. 3.
Yes.
3.
Yes.
3.
Yes.
Wait, yes.
Now, I'm wondering about that. What's 8 plus 7?
15.
Plus 6?
21.
21 is divisible by 3, so the whole number is divisible by 3. 5.
No.
6.
Yes.
Oh, yay.
Yes.
6 finally gets some love here. It is 876 is divisible by 6. And 10.
No.
Again, 10 is not it.
I said yes because I have it. I knew it was a habit.
Are you a yes person? I'm just kidding, Sarah. All right, how about this, Sarah? Just for you. Number 9. Everyone do number 9. Yeah, but it's... Gotcha. No, I would just say in commemoration of her answer. So number 9. That's 50 or 5010. That's okay. I wanted you guys to do number 5 or number 9 anyway. Okay, let's go ahead and go through this. 2.
Yes.
Nice. 3.
Yes.
5.
Yes.
6.
Yes.
10.
Yes.
Bonus.
Yes.
By 4.
Yes. Yes. No. Yes. No. Yes. Yes. Yes.
What I do is this. I look at the last 2 digits.
No.
Is 10 divisible by 4?
No.
No. All right, ready? Bonus number 2. Is this divisible by 4? So hold on. I need someone to give me a firm answer. Is 76 divisible by 4?
Yes.
Yes.
19.
Yeah, 19 times. Thank you. 39 by 4. Is it divisible by 4? No. And then, yeah, you can divide it by 4 if you wanted to. Okay, anyway, let's go to the last part here. Last part. So this was for you, Sarah. You could say yes, 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 and yes. Which is nice. Uh-oh. Sorry. We're going to go to page now. We're just almost at 172. Last part. Oh, my. Monomials. Okay, monomials. Super important concept here. So stay with me here. Okay, ready, guys? I asked a question before, like, do you know have you heard of the term monomial? And most of us said no. That's okay. Some of us have. Good. But a monomial is an integer. We've heard of that term before, I hope. It is a variable. So we've seen that. Or a product. Yes, please. Yes, you need this. A product of integers. And I'll get out of the way in just a moment. And variables. That's what a monomial is. That's the definition.
Pretty much sums up all of them.
Close.
Look.
Yeah, because we're going to see some examples that yes, they are monomials, and no, these are not monomials. Okay, so monomials, and I'm sorry, that's not parallel. That should be monomials are integers, variables, or products of integers and variables, but I think you get it. Sorry, it's that S that throws me off. There you go. Monomial is an integer, a variable, or a product of integers or variables. All right, have we seen integers before?
Yes.
What is an integer? Someone raise your hand and tell me. Give me a definition. I need it. Yes, Betsy? It could be a negative number. I need more of a strict definition here. Sarah? So you could do that with integers, but I want what an integer is. Nick? It could be used with inequalities. Josh? Okay, ready, guys? Here it is. It's any whole number and its opposite. Okay, so you guys remember 0, 1, 2, 3? Those are integers. Do you guys remember -1, -2, -3? Those are also integers.
So integers are just numbers?
5 and -5. Just numbers that we dealt with so far, but there are other numbers.
Value of the number?
It depends if the absolute value is going to be an integer. Yes, it is an integer. But we have fractions and decimals. Those are not integers. So yeah, integer. You've seen variables, I hope. And then, does anyone know what the word product means, Josh?
Product is answer to the multiplication.
Very nice. So a multiplication problem with integers and variables, or integers or variables. Okay. So here I'm going to give you some examples of what a monomial is. Like, Mr. A, isn't everything a monomial? No. Oh, here are some examples. The letter Z. That is a monomial. Why? Because it is a variable. So easy. It's a variable. It's a monomial. Okay. Here's another one. 16. Is it a monomial? Yeah, because it's a...
Product of an integer. No?
It's just an integer. 16 is an integer. That's all right.
It could be a product, though.
It could be made into a product. That is correct. MN. Why? It's a product of two variables. So that counts. And then another example, 6AB. Is that a monomial?
Yeah.
Because it's 6 times A times B. So those are all examples. Those are good. All right. I'm going to put here not monomials. I'm going to give you some examples of non-monomial terms. Okay. First one I'll give you is 4x minus 2. That's not a monomial. Because it has this in it. Subtraction. That's it. Not a let me clarify. Just subtraction. But you're good. You're good. I mean, I think that's what you're saying. It has subtraction, not a monomial. Next one.
Wait, just because it's subtraction?
Just because it has that subtraction sign. Yep. That's the only reason it's not a monomial. So it does have, if this were it, if it was just 4x, monomial. But now when it's 4x minus 2, not a monomial. Next one. X plus 3. Now that's got to be a monomial.
No.
Why not? It has an addition part. All right, so it has addition. Not monomial. Do you guys understand? Monomials are basically the most basic parts of math in algebra. Okay, question? Rachel. Same thing, yeah, not monomial. Although I need to make that clear later. So don't worry too much about division until I give you that. Okay, because there's something about it I need to clarify it, but later. Okay, example number 4. Let's just finish this off. Last example, and then I'll give you your time. Okay, example 4a. Determine whether each expression is a monomial. A, is that a monomial, everybody?
Yes.
Oh, I heard yes and no. A, example 4a. Is it a monomial? No, because it has addition. Not a monomial anymore. B, is B a monomial? It says negative 25. Is negative 25 an integer?
Yes.
So it is a monomial. All right, so B would be monomial. Yes, ma'am.
Why would it be a monomial? It's like multiplication.
So a product of variables and integers is a monomial. So you see how negative 25 times x times y times z, that's a monomial. All right, your homework. I don't think so. Shouldn't be. All right, your homework. Let me write it down, then I'll give you your tests. Yeah, I graded it. Thankfully, I was able to grade them. 15 to 35. Oh, my. Odd.
Oh, yeah. So it's 15 odd. Yes, it is.
I broke down. All right, and then listen carefully. It's 15 to 35 odd. Those are the odd ones. But then this is 45 through 50. So that's 45, 46, 47, 48, 49, and 50. I think I said something twice. But anyway, that's all of them in between. They're are not odd. They're all. So yeah, just make sure you do them all there. 173 to 174, and that's due tomorrow. And I am going to stop Swivl.